Yeah, hi, good evening, everyone. Welcome to the revision session after a very long time in C. So, I hope you have done some revision for the C programming because your exam is on coming Sunday, and we have also released this mock paper, okay, on the portal. I hope you tried that. So,
Yes, sir.
okay, so what's your feeling about difficulty level of your of this mock?
Sir, most of the questions were easy, except two to three questions I could solve everything.
Okay, you have solved. Okay, okay, nice. And others, what's your feedback about the difficulty level?
Yes, sir. Except some output questions, I was able to solve the mock test.
Okay, okay. So yeah. So today our plan is to discuss. So we cannot teach everything in the first 4 week, but we will focus on the important topic of the first 4 week, where you should focus more. And we have also released some week-wise notes. I am not sure you are aware of that in the supplementary content. So let me share my screen and where you can see this. Okay, I hope my screen is visible.
Yes, sir.
Okay, so in your course page, inside the supplementary content, we have released this week-wise summary notes where you can find out the one drive link, and inside this drive link you will see the week-wise notes. Okay, we have just created some summary notes for each week, and you can go through these content. You have already learned the week first 4 week content. Now you can just open this document and just revise, just recap this. Okay, so I hope that these will also be helpful for you in the exam.
Sir.
Okay, so and with the help of these notes, I'll just quickly recap all the concepts or basically important things. Okay, so we are not covering all the things in detail, but revise all important things which you can focus more. So week wise we will go. Okay, so and after completion of this we will also discuss the solution of that or we will discuss the solution of mock questions once our week is completed. Okay, so after week one discussion, and then we will just try to cover our mock questions on the portal. So in that way we will revise the things, and we will also solve the mock papers, that mock exam. Okay, so now the things first week. Okay, now quickly check. So week one was basically about the computer introduction. So what is computer? How computer works? What are the basic internal parts of the computer? And so that things and how they communicate to each other. What are the computing and how we perform that computer perform the computing. All these basics are actually discussed in the week one. So that we will discuss these theory, some important points. So computer, you know that it is electronics device that process the data, that takes some input and that process that input and return some output based on the problem. Okay, it perform calculation, execute instructions. So that means if what computer actually does, it takes some set of instructions. Okay, so computer is just a that electronic device. It will not do anything by your own. So we actually provide some set of instruction or sequence of instruction. Computer just takes that sequence of instruction and execute in the given sequence. So that sequence actually we designed. So that is called as a programming. So we just write some sequence of instruction in the form of program, and that program is executed by the processor inside the computer. So in that way, that computer actually compute the calculations or the task. So what are the parts of basically computer have? So key component of computer you can see. These are some common key component. That first is, this is the main component actually, CPU, central processing unit. Okay, and sometimes we also call it as a brain of the computer because it actually perform all the computation inside the computer. and it actually execute all the instruction and perform the calculation. So inside the CPU we have some part. Actually the main part of the CPU is actually a control unit and arithmetic logical units, is this ALU. Okay, so arithmetic means arithmetic operation and logical operation. So this unit actually perform these operation, arithmetic operation and logical operation. Apart from that, it also have a control unit, so that actually manage all the instruction, which instruction will execute, and data transfer from memory to CPU. So that part actually handled by this control unit. This control unit actually work as a to control the uh, data communication, instruction communication, like this. Okay, so this according to that name is also given to you, given to it, control unit. Apart from that CPU, so the another key component of the computer is memory. Because if we are performing any task, so we have some input data, so that input data should also be stored in some place. That after that, that if our computation is happening, so temporarily we need to store the data, and finally we need to return the output, so that output will also be stored in some place. So all the that instruction data all are stored in our in some place in the computer, so that is called as a memory. So this is called as a storage device. And there are multiple types of memory. So the main memory actually which CPU actually needs it, uh, that is called as a RAM, random access memory. This is a volatile memory. Volatile means if our power is lost actually, so data will also be removed from this memory. So in general, the task and the any computation is happening by the that CPU. So related program or related instruction and related data actually comes into this memory, and that instruction executed by the CPU. And after that, if our task is completed, so that data and instruction is removed from this memory. So this RAM is actually store the data which are actually actively running at the current time, okay, by the CPU. So temporary storage used by actively running programs and data. Data can be read from and written to RAM quickly. So this RAM is actually closer to the CPU. So the communication happen fast with the CPU and this RAM memory. So this is a volatile memory, meaning data is lost when the power is off. So this is the one type of memory. Apart from this memory, so this memory actually only contain the data which is actually using in the current executing program. But we need to store some data permanently. Okay, so that we have the another type of memory that called as a non-volatile memory. So that retain the data even when the power is off, actually, of the power of the computer is off. So that data remain inside the memory. That will not be deleted. So we use this storage for the long-term storage. And like this example, hard drive, HDD, that solid state drive. Now this is the current popular SSDs and external storage device, like here that we have pen drive or USB, anything, any external hardware soft or that storage device. So this
Sir,
is the yes.
sir, your voice is breaking.
Okay, is it for everyone? Hello.
That's fine for me.
Okay. So am I audible right clearly now?
No, sir. I think it's problem from my side also.
Okay, so just check your internet connection. Okay. Hmm. So let's move to the next part. Okay, storage device we have discussed. An input device where from we are taking the input, like keyboard and the touch screen. Sometimes also work as an input device. Our mic is also work as input device. So that device which are actually used to give the input to the computer. So that is called as the input device. Output device basically where from we are get the output, like in the form of display or voice or printer or headphone, speaker, all are actually these the output device. Motherboard just a circuit which is located in the computer that contain all the component of the computer, okay, and communication in between them. This is just a circuit inside the computer. And software, so this is just a program and instruction that tell the computer what task to perform, so including operating system. So this is the main this is also a software that actually run another softwares. Okay, so this is the main software of the computer. So our other application run by through this operating system. So that another application for any specific task, like we run the VLC media player or any browser we are running. So many type of application we runs on the computer. So that is called as a application, and utility software like drivers are required for some application or software. Okay, so now if we just look this CPU diagram, so yeah, this is the main central processing unit. So here you can see this is the architecture of the computers, or we can see that that main component. So this is input part, this is output part. In between, we have this block. So inside this is the main block CPU, and CPU contain this ALU. Okay, so that this combine this part. Okay, and this completely considered as a ALU, arithmetic logical unit. So, and apart from this ALU, we have also registers. So these are also a type of memory that actually store the temporary data which are actually required by the processor at the time of computation. Okay, suppose we are performing like a plus b, this operation we are performing, and we have some data for a and b. So that data is actually stored inside the register. So this is the smallest unit of the memory. So that store this data temporary, and after execution of this addition, you will get some result. So that result will be also be stored in some registers. And during the computation, we need some memory. So that actually memory provided by this register to that CPU. Okay, so that is called as a registers. Next level memory, we have this main memory. Okay, so processor actually communicate to these registers for the temporary to temporary store the data, but we need to store more data that is actually stored in main memory. So the main complete program and complete data is stored, but what instruction is actually executing at the current time, so that instruction will come into this registers, and that our ALU will perform the operation, and after that output will be stored into the register, and after from register our data will be moved to this main memory. So our processor actually execute instruction by instruction, so one instruction at a time. Okay, so that means what data and what instruction are required at a time, so that only will come fetch from the main memory and will store into the registers, and after completion of this execution, so that will be moved to the main memory. So these are the memory we know that what is the closest memory of the CPU. This is registers. After that, main memory, then secondary memory. Okay, and this is the sorry, control unit that actually manage all the things. So which instruction will execute, what will be the data transfer, how data transfer will be performed from the main memory to registers, all things managed by this control unit inside the CPU. So these are key components inside. Some more important points are like control unit. What control unit actually provide this manage and coordinate all the operation of CPU like this. ALU is the main thing, so that perform or all mathematical calculation, addition, subtraction, multiplication, division, or logical operation, and or not decision making, this type of operation. So this is the main that computing unit. After that, registers are small and high speed memory located within the CPU. Okay, inside the CPU, that all registers so are stored, and that store the data and instruction temporarily during the processing. So inside this registers, we have different types of registers also. So that one is program counter, another is instruction register, and general purpose registers. So what is the role of program counter? So program counter actually store the instruction which will execute next. Okay. So what instruction is executing at the current time? Okay. That will store inside this instruction register. But what instruction will execute next after the current instruction? So that will be stored inside this program counter. Okay, so program counter stored the instruction which will execute next. And general purpose registers are actually to use to store temporary data during the computation. Okay, if we are getting some addition of two value, subtraction of two value, or multiplication of two value, if we are getting some result, so that actually we store inside the general purpose registers. But these two are actually specific registers, so that store some specific data. So this is also important. So now function, this is the another thing. So instruction, executing, data processing, all these are actually function of this our CPU. Okay, so what are the function? Instruction, execution. So it actually fetch the instruction from memory. So instruction are actually formed in some coding, that encoding, so that decoded actually in decoded instruction to determine the operation to be performed. Okay, so that this is the actually function by the CPU. So that actually fetch the instruction, then decode the instruction, and then perform the execute the instruction by performing calculation and data manipulation. And this is the part of execution. Another part is data processing, so perform arithmetical and logical operation on data. Okay, so this type of operation performed on the data, process data in accordance with the instruction provided by the software or
Sir,
application. Yes.
sir, in this week one lecture, will they ask uh, like MCQ and true or false, or they'll ask some theory questions like that? The
So
theory lecture.
question will be very similar to your weekly theory assignment.
Okay, sir.
Okay, so weekly assignment you have seen in the week one, week two, and mock
Yes, sir.
also. So week one
Yes,
is
sir.
basically theory questions. Some question maybe you will find like this, that memory computation we have discussed in week one. So some
Okay, sir.
registers data like that. We will also discuss this from the mock questions. Okay. Yeah.
Okay, sir.
And
Thank you.
another, so this is the control of peripheral. So peripheral means that another device which are connected to the CPU. Okay, so that communication, all these things are managed, and memory management. So one second. So after that, we should also know a little bit about this memory hierarchy. So we have seen that we have this is the closest memory. So this is the CPU, and near to CPU we have registers. This is the closest memory. And is after that we have cache memory. So cache memory we have not touched actually. So this memory is actually used in between main memory and that registers. So why this is used? So cache memory basically store the data which actually frequently coming into the processor. Okay, so suppose sometimes we are performing any task and any instruction which are repeatedly coming to the CPU to perform. So that instruction or data actually temporarily stored inside this cache memory. So what happens sometime, if next time we need this instruction which are frequently coming, so that will be checked inside this cache memory first instead of the main memory. And if it is available inside the cache memory, so we will directly use from the here. Okay, so CPU directly use from this that instruction from cache memory. So that actually will saves some time during the communications. Okay, so this cache memory is more closer to the main memory. So if any instruction or data frequently coming to the CPU, so that will store temporary for some time in cache memory, and next time it will directly fetch from the cache memory. So it will save our time for the computation. So this is the purpose of cache memory. And after that, our main memory actually comes. So so this is the closest, this is the next closest, this is the main memory. This is also a that store the data temporary. So that actually store the data which related to the any particular task or program. Suppose you have write a program to addition to value. Okay, so you have write some code set sequence of instruction for that, and so that if you are performing if you are running this program by the computer, so that complete program will come into the main memory first. After that, each instruction will be moved to the CPU one by one. That CPU will execute it. So related data, if any data is required, so that will also be moved to the CPU, and that operation will be performed, and then next instruction will be performed. So in this way, our complete program and task related data comes in the main memory first, and after that, current instruction which we are executing, that will be moved to the CPU. And after that, all these lower storage are actually that fix our permanent memory, like magnet disk, optical disk, magnetic tape. So where our data is stored actually permanent. So like if our when we write our any program, so we store that program in some file. So that file is actually stored permanently in this part. Okay, but when we are running that program, so that program instruction will be moved to this main memory, and that will be executed by the CPU. Okay, after completion of this, this program will be removed from the main memory, and it will update inside the permanent storage. Okay, so according to this communication distance, so this is the access time sequence we have. So that means C registers are the fastest memory. Okay, and for the CPU, then cache memory, then main memory. Okay, so access time increasing. So you can see that direction is this. So access time means CPU is taking less access time from registers, then cache memory, then main memory, then largest to the magnetic disk. Okay, and same way this side is it is showing that capacity. So capacity of the registers is very low. Okay, and cache memory is a little bit high. Then main memory we have some more memory like GB, and then magnetic disk we have lots of GB or like sometime terabyte. Okay, so and that price, that cost is also decrease. Cost actually decrease when we move to the CPU to this register to magnetic tape. So this register are actually more costly. So according to the storage, so how much we are store, what is the size of the storage, corresponding cost is very high for the registers, and the cost is very low for this magnetic tape this side. Okay, so cost actually decreased from register to this permanent storage, but capacity increase and access time is also increased. Okay, so this relation you can just note down. So we have discussed all the topic one by one in this file. And after that, what is programming? So programming is just a sequence of steps, of sequence of instructions, or sometimes set of structured instruction that we write to perform any task. So that is called as a program. Okay, and before program, we initially we just write a set of step in our normal language, like we can just say that here programming is just follow some proper syntax or rule, but before that there is one term algorithm. Okay, so algorithm is called as a set sequence of steps, but that steps are not required to written in some specifics with any specific syntax or rule. So you can easily write that steps in your language. Okay, so that is just uh, describing the sequence of steps that will actually solve your problem. Okay, in any language. But when we convert this set of sequence into any specific programming language, like any C or any Python or any language, so that is actually called as a program. Okay, so for programming we need something, so we need a language, so that actually provides some formal language syntax. that provides some syntax, uh, semantic means rules and regulation for the programming language. And like this example I've given, C, Python, Java, all are programming language. Apart from that, we need algorithms. So algorithms are actually step by step sets of instruction used to solve a specific problem or perform tasks. So this is basically a logic to solve the problem, okay, which we have written step by step. And this algorithm will be converted into a program with the help of programming language. And to because every problem perform on some data, okay, so we perform any problem on some input data, like we are sorting some data, we are searching something from the data. So that means we need some storage uh, to store the data, and that data should be stored properly so we can use that data efficiently when we are using in our program. So that programming language also provides some data structure. So data structure is just a way to organize and store data efficiently, okay. So that is discussed, I think till b4 it is not discussed. But that array actually store the data in proper structured way. So like there is one example array, so that is actually a collection of elements. Suppose we want to store more than one elements, okay, in our program, okay. So we can use the array data structure which provided by the C, where all data is stored actually in the continuous memory locations. So later like 10, 20, 30, 40, like this. And later if we need this data to perform any task, so we can simply access all the data one by one. So the if we know that first data is stored at this place, we can get the second data to the next place memory, then third data, then fourth data, like this. So we can traverse all the data. We no need to store each memory location, okay. We only require the first memory location. After that we can traverse all the locations, so all are actually consecutive. So this type of many data structure actually programming language provides us, so to just help help to help for us to solve any type of problems. So that is called as a data structure. And this is more later part, actually software development cycle. So when we design any application, so we have some sequence of steps to develop any application. So that is not required to discuss actually. So purpose of programming, these are some application. We have automation, problem solving, software creation, innovation, analysis, or there are many things we need actually in the today time, where we need this programming things, okay. And programming process, this is the just steps. You should know the problem should be clear first. What is the problem actually, okay. Then designing the solution, you should know how that problem can be solved on paper and pen, so you can simply write the steps of solution. After that, convert into the code. Then test your code, it is working fine according to your problem or not. Then if your problem is working fine, then this is the high level steps, optimization. So that means improve the efficiency of your code. That means your program should work fast, okay. There in the programming there is a multiple possibility that any problem can be solved by different method. So which method is actually performed quickly or fast in less time, so that is actually called as a optimization. So how we can improve the speed of the code, or we can improve the space required by the program. So that is actually called as a optimization, but that is not part of this course. And documentation, we should also manage the proper documentation of our program functionality. So this is the programming process, but in this course we are only focusing only till this part, okay. These part are not um, covered in this course, okay. So these are the later part actually. And types of programming: application development, web development, this embedded programming, these are some application, and these are tool we use generally over some IDE, integrated development environment, that provide the editor and compiler the built all built in the combination form. So where we run our programs, editors, version control, all these are actually little things. And this is little bit about the introduction of C language. So C level language is considered as a middle level language. So why middle level? Because it is very closer to the machine. It provide the pointer concept that we can access the memory directly by the address. Because of that, it comes to the lower level side. Otherwise, it also provide the high level that features that we can directly perform, like this uh, functional programming loop, or all these type of higher level language things. So because of that, this is also a high level language. So because of that, both feature high level and low level concept, we generally use the term middle level language for C. Okay. Otherwise, these are some key characteristics. You can just go through these and just note down this. And this is some one basic example for the basic syntax. Okay. So this is all about the week one, and let's move to the week one question that inside the mock. One second, mock unit. So first question we have this let R0. Okay, so here these questions are based on some this memory model computation, so which is discussed in the assignment also. So here R0 be a register and M0 be a memory location. Okay, consider the following two instruction. So what is the first instruction we have? You can see the arrow. Okay, so arrow means right side, that value is actually storing into the left side location. So this instruction actually reads like this: data from the right side location is actually storing into the left side location. Okay, so all these are actually storage location. So register also a memory, M0 is also a memory. So what we will write here, a second instruction is data from R0 is storing into the M0. So which instruction are correct for this? So we will read the instruction one step by step, and you can just note point out that which instruction is correct. So instruction one is a load operation. Okay, whereas instruction two is a store operation. So load operation is the when we fetch the data from memory and store into the register. So that is called as a load operation. And store operation, when we store the data of register into the memory. So that is called as a store operation. So this is all these operations are related to the memory. If we are reading some data from memory, that is called as a load operation. If we are storing some data into the memory, so that is called as a store operation. So here instruction, that step one is that option one is actually correct. Okay, so here we are reading the data from memory and storing into the registers. So that means we are fetching the data from memory and storing the registers for CPU. And here from registers to memory, so here we are storing the data into the memory. Okay, so option one is correct. Okay, and this second instruction one is a store operation. This is just a reverse, so this is not true for this. And second question, which component of a computer system is responsible for non-volatile storage of data and program? Okay, so here we have discussed that non-volatile storage. So non-volatile means permanent storage. So after power loss, our data will not be lost. So here main memory, as we said that this is a non-volatile storage. Okay, so this first thing, main memory is a memory, but this is a volatile memory which store the data temporarily. Okay, if our power is lost, data will be lost from this memory. So this is volatile. CPU is not a memory. Okay, CPU is a that unit that contain registers, logical unit, all these things. So that not comes as a memory. And this is also execute the instruction which are actually currently using. And secondary memory, as we have discussed, this store the permanent data. And registers also use as a temporary storage, so that only store the data which are actually executing by the CPU at a current time, so that is also not permanent. So the secondary memory actually is a non-volatile memory and store the data permanently. So for second question, the secondary memory is actually the correct answer. And which of the following are example of secondary storage device in a computer system? Okay, so same. This is again the similar question. So what are the secondary memory we have in the computer? So you can see registers is not the secondary memory. Cache memory is also not secondary memory. RAM is also not secondary memory. Uh, and these USB flash drive, hard drive, SSD, all are actually permanent storage, and these are called as a secondary storage device, non-volatile device. Okay, and after that, how many bits are required to encode a string? Okay, so this is the next second big things. Okay, so this question is coming from the big two. Okay, so that we will discuss. And next is, which component of the computer system is responsible for fetching instruction from memory and executing them? Okay, so here, which one is the correct?
CPU.
Yeah, CPU is the correct answer here. So because CPU actually fetching instruction from memory and executing, so the task of the CPU is actually executing the instructions. So this is the main answer. This RAM is just a memory, hard disk is a permanent memory. So all of the above, this is not possible. So only CPU is the correct answer. And regarding this fourth question, actually, 7-bit. Okay, so how many bits are required to encoding a string using 7-bit SKA? What is this 7-bit SKA? So okay, okay, so this is string. Sorry, yeah. So here it is mentioned that how many bits are required to encode a string IITM. Okay, so 4 characters are there using 7-bit ASCII code. So in 7-bit ASCII code, each character is represented by 7-bit. So here 4 characters are there. So 4 into 7, 28. So you can directly calculate this. 28 is the answer. So now after that, yeah, this is the first 5 question we have seen. Now we have the programming question. Okay, so that we will also discuss. Okay, that conversion is also required. Okay, now move to the big 2. Big 2. Okay, so big 2 is basically a that describe the data representation in the computer. So how data is actually represented by the computer, and what are the some conversion or these things operation are discussed in big 2. So number representation is the first thing, binary number representation. So computer actually understand only this binary language, so this 0101. So 0 and 1 binary means we have only 2 digit to represent any data. Okay, that you have already seen decimal. So decimal means you have total 10 digit, so 0 to 9, you have total 10 digit to represent any data, so this is called as a decimal. Binary, you have only 2 digit, 0 and 1. And octal, there is a one another representation, that means 8. Okay, so 0 to 7, you have these two, total 8 digit to represent any data. Another is hexadecimal, so hexadecimal, and that contains 0 to 15, 0 to 15 different digit to represent any data. So here 0 to 15 digits are actually this is not represented as a 15. So after 9, so after 9 we write as a B, C, D, E and F. Okay, so 10 is represented by A, 11 is represented by B, 12 is represented by C like this, so 15 is represented by F. So but we have this representation 0 2 0 1 2 3 2 9, then A B C D E F. So this total 16 digit we have to represent any data. So these are very common representation, number representation in our computer. So binary is actually the main computer representation. So 0 1, and in electrical form, so 0 is represented as a low voltage, okay, and 1 is represented as a high voltage. Okay, so because of that, our data in our computer, every data is actually stored in the form of electrical signal. So that means low signal is 0 and high signal is 1. So because of that, this is the main machine language we have, that contain only 0 1 data. And so now you can see binary number representation. That means every data can be represented by this binary representation. So we have 2 digit, and this is called as a binary code, which is used by the computer and digital system. And we can represent any data like this. So this 1011 is the representation of decimal 11. Okay, and the base we call as a 2. 2 means 2 digit we have 0 1, and base, if we have base 10, 10 means 10 digit decimal number. Base 8 is representing to octal. Base 16 is representing to hexadecimal. So now the things is we have discussed this four type of representation. Now the very important questions is here to conversion. So if we have a number in one form, how we can convert into the another form? Okay, so you can see octal representation, as I mentioned that, and decimal representation, hexadecimal representation. So these four representations are there. Now first basic is, if you have any decimal representation, how you can convert that into a binary, octal, or decimal, that hexadecimal. Okay, suppose if you have 20 in decimal base 10. Okay, this is the decimal number 20. How you can convert into a binary number base 2? So we are converting this decimal to this binary number. So what we will do, we will perform the division method. So there is one method called as a division method we can perform. So like we will divide this number by 2. We are converting this decimal to binary, so we will perform the division by 2. Okay, and we will store the remainder every time on the right side. So when we are dividing this 20, and we are getting 10, and here we are getting 0. Okay, no reminder. Okay, then this is the quiescent value, and again we are dividing this, so we are getting 5 here, and remainder is again 0. And when we are dividing again, so 2 is 4, 2 2 is 4, and remainder is now 1. Now again we are running, so 2 1 is 2, so 1 we are getting, and remainder is 0. Now this is the only, again we are dividing, so we will get 0 and remainder is 1. Okay, so we will repeat this process till this 0 value, and we will note down this remainder, and after that we will read this remainder from bottom to up manner. Okay, so like 1 0 1 0 0. So this is the equivalent value of the 20 in binary. Okay, so this is one division method you can perform for any conversion from decimal to any conversion. So like same 20, how we can write into the octal form. So 10 into octal form, 8. So what we will do, we will divide from 8 this time. Okay, so 8 1 ja 8, 8 2 ja 16. So this time 2. Okay, 2 ja 16, and remainder is 4. Okay, now 8, so this is 0, and remainder is 2. So now read this like this, and it will be right as a 24 base 8. So that means decimal 20 will be written as 24 as a in the octal representation, 8 representation. So same way you can convert this into a hexadecimal. So that for hexadecimal, divide by 16. So 20 and 16. So this 0 and 16 1 ja, sorry, 16 1 ja 6. So the remainder is 4, and this time 16. So 0 and 1. So 1 4. So 1 4 is the hexadecimal representation. Hexadecimal 16. Okay, 2-digit representation. So in this way, you can use this division method and convert any decimal number to a binary number, a octal number, hexadecimal number by this division method. And another way is like if you have like binary number. Okay, so suppose if you have given like 1 1 0 1 1 1, what is the, this is binary, what is the equivalent decimal number? Okay, decimal number. So for this representation, you can perform the multiplication like this. So you have this 1 1 0 1 1 1. So here you can start like 2 to the power 0. Okay, so start from 2 to the power 0 and move to the your left side. 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. Okay, after that just do the multiplication and sum. So this is the multiplication and in between sum, this calculation like this. Okay, so 1 into 2 to the power 0, 2 to the power 0 is 1 1, so 1 plus 2 to the power 1 is 2 2 plus 2 to the power 2 4 into 1 4, 2 to the power 3 8 into 0 0, 2 to the power 4 16 into 1 16, and 2 to the power 5 32 into 1 32. Add this 48 52 54 and 55. So 55 is the equivalent value of this. Okay, if you want to convert any, suppose if you are given as a octal number, okay, so in that case just replace this 2 by 8. Okay, to convert, so just replace this 2 by 8. And if you want to convert into the hexadecimal to decimal, just replace this by 2 by 16. So this is the only change you need. Okay, so this is the conversion of any another base number to a decimal number. So this is the method. And apart from that, sometimes some conversion is also required, like hexadecimal to binary number. So suppose if you have that A15, this is the hexadecimal number, and you want to convert into a binary number. So binary number. So we know that we have total 16 digit. Okay, so 1 2 3 4 5 6 7 8 9, then A B C D E F. Okay. So equivalent is 10 11 12 13 14 15. So hexadecimal we have total 15, total 16, sorry, 0. So 16 digit, and to represent the 16 digit we need how many bits? At least 2 to the power 4. Okay, because if you have one digit to represent, if you have one digit, so you can either write like as a 0 and 1. So that means if you have one digit, you can only represent two values. So 2 to the power 1 equal to 2. Okay, so this 1 is representing number of digit. If you have two digit to represent any number, so you can represent four different numbers. So like 2 to the power 2 equal to 4. So that means 0 0 0 1 1 0 1 1. So these are the four combination with two digit. Okay, if you have three digit, 2 to the power 3, you can represent eight different numbers. So like 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Total eight possibility are there. Okay, 0 in the 0 1, so 8. So similarly, to represent 16 you need at least 4 digit 16. So because of that, what we will do, we will write a equivalent 4 digit binary number for A 1 and 5 each. So then we can convert that into a binary. So what is the equivalent? So this A is actually 10, and 10 can be represented in the binary form 1010. If you convert, you can simply convert this 10 by dividing 2, like this division method, you will get this 10110. So this is 4 digit value for A. And what is the 4 digit value for 1? That is actually 0001, this one. Okay, so this is the equivalent of 1. What is the 5? So 5 is actually this one. Okay, so equivalent binary representation of 5 is 0101. So this is the 5, and this complete number is representing a binary. Yeah, anyone have any query? Someone open the mic. Yeah, Niranjan, do you have any query? Okay. Okay, so let's move to this. And so in this way, any hexadecimal number, this number can be directly represented into the binary by 4-4 combination. Okay, so 4 digit, 4 digit, 4 digit, just you can write like this. And similarly, you can convert this into in this form. So if you have suppose given like this binary number, so 1010010111110, and we are asking that what is the equivalent hexadecimal. So hexadecimal represented by 4 bits. So just take 4 bits from the right, okay, and just write a equivalent decimal number. Okay, so this 4, and this time 3 is remaining, so just put 10 before that, so it will not change the value. Okay, so just what is the equivalent value for this first 4 digit is actually that E, 15. Okay, no, not 15, sorry, 14. So that is equivalent to E. Okay, this is the equivalent of 2, and this is the equivalent of 1015. So 5 to E is the hexadecimal equivalent for this. Okay, so in this way you can convert one number to the another number hexadecimal. And suppose octal is given, generally we not ask for the octal, but you should know if like 147, this octal value is given, and what is the equivalent of binary number. So in this octal representation, every octal representation can be represented by these total 8 bits. Total 3 bits. Okay, 3 bits are required to represent. So you can write a equivalent 3 digit for every number. So what is the equivalent of 7? This is a 111, and 4 100, and 1001. So this is the binary equivalent of octal number. So this is 2. And same way you can convert this side. So just pick 3 digit from the right and write equivalent value, decimal value. So in this way you can convert this number. So this is the number conversion and conversion between number systems. So we have discussed the division method and hexadecimal, this conversion binary to hexadecimal. Yeah. So this number is conversion is discussed. Now negative number representation in the computer. So there are 2 methods discussed. So first is sign and magnitude. Okay. So sign and magnitude, what is this? So the MSB bit, most significant bit. So that means if we have any number 0101 like this, so this is called as a most significant bit, and this is called as a least significant bit. So here the most significant bit we used as a sign. Okay, so 0 means that positive, okay, and 1 means negative. So 0 for positive and 1 for negative. So most significant bit we used as a sign, and remaining bits we use as a value. So here this is the representation plus 18 in the 8-bit system. So the 18 equivalent binary is this 10010, and we have 8-bit system, so we will use 3-bit remaining, but the first bit will be represented as a sign plus. If negative 18 is there, so we will only change the first bit to a 1. So now the 7 bit will be used for this value, and first bit will be used as a sign. So 1 for negative and 0 for that positive. So this is as a first one representation. So in this way, how many number we can represent? Suppose this 8-bit system is given. Okay, so 8-bit system is given. That means we have the 7 bit for the value only. So that means 0 we have. Okay, after that 1, 2, 3, and for 7 bit, how many number we can represent? 2 to the power 7 and minus 1. So but this is the maximum value. Okay, so that means 128, 127. So 0 to 127 this side, 127. So that means we can represent these number onto the right side, and because we are only using 7 bit, okay, So 7-bit we are using for number. So because of that, we will get this representation on the positive side, but negative side also, because only one bit is representing the sign. So we will also get like this representation 1 0 0 0 0 0 0 or one more 0. So this is the value and this is the sign. Okay. So what this value is representing? -0 actually. Okay. So in this that representation sign and magnitude, we have this drawback. We have the two representation for zero value. So another is like 0 0 0 0 and 0 0 0 0. So this is for positive and this is the equivalent to 0. Okay, same here. This is equivalent to 0, but this is the negative. So that means -0, we have one representation, and this side we will move to -127. Okay, same. So that means total we can represent 2 to the power 7 number. This is 128. That means 0 to 127. Total 128 numbers are there, positive side, and -0 to -127. So this is negative side. So again, this is the range of 128 total. So we can write like this. So that means on the positive side, we have this 2 to the power that 7 minus 1, and same 2 to the power 7 minus 1 we have on the this side. Okay, so this is the sign and magnitude. This drawback actually two representation for 0, positive 0 and negative 0, and this is resolved in this 2s complement notation. Here we represent the negative number in different way. So positive representation we done in the same way, okay, as the previous. So 7 value 7 digit will be represented as a value, and first bit will be represented as a sign. So this is the same, but negative representation we can use the complement, actually 2s complement. So what is this 2s complement? So for -18, we will write a 18 equivalent number. So 18 equivalent is 0 0 0 1 0 0 1 0. Okay, so this is the 18 plus 18. But for that make negative this, so what we will do, we will convert this into a 1s complement. 1s. So 1s complement actually convert all digit, invert all the digit actually bits. So 0 to 1 and 1 to 0. So that means if we convert this all 0 to 1 and 1 to 0, so we will get 1 1 1 0 1 1 0 1. Okay, I have invert all the bits. And to convert this into a 2s complement, we will add one value, that 1 into at this place, plus 1. Okay, so this is the number 1 plus 1, that we will get that 1 plus 1 0. So 0 will come here and 1 will come as carry, and that 1 plus 0 will become a 1. Okay, remaining will same. So 1 1 0 1 1 1. So now this is a 2s complement, and this is the representation for -18. So that means for negative, we will convert the positive number into a 2s complement, and that is represented as a negative representation for 18. Okay. So here we have only one representation for 0. So we are not getting two representation for 0 this time. So in this way, we are utilizing all the representation here. So 0 to that 127, and this side -1 to -128 this side, not -127. Okay, because we don't have the representation, two representation for 0 now. So we will use 128 value from this range, and this is 128 this side. Okay, so this is the range we will get by this 2s complement. So this is important. Floating point representation you can just quickly view, but this is not important. The paper, this is in more deep. Yeah, character representation, we use this as sky characters, this representation. So this is also not too much in detail, but yeah, some questions are asked like this. So if we have 6 bits, okay, if we have 6 bits, what is the range to represent the how many characters we can represent with the help of 6 bits. Okay, so we can directly calculate this like 2 to the power 6, total 64. 64 unique character we can represent by the 6 bits. And if we find out the range in the integer, so that means 0 to 63. Okay, so this is the range, but total values are 64. And sometimes the question asks like this, so if we have 25 different characters, okay, so how many minimum bits are required to represent this 25? So you need to figure out that which 2 to the power value you are getting more than and closer to this value. Okay, suppose if you are taking 2 to the power 4, you are getting 16. So that means 16 are not enough to cover 25. So we cannot take this. Okay, 2 to the power 5. So now this becomes 32. So 32 is more than and closer to this. So that means this is the 5 bit is enough to represent 25. Some representation we will remain empty, but we can represent this 25 with the help of 5 bits. Okay, so this is the minimum requirement 5. Otherwise, you can take 2 to the power 6. This is 64, which is also greater than this. But this is closer, so we will take this form 5. Okay, so this is the minimum requirement. This 5 bit are required to represent this 25. So this type of question is also asked regarding the minimum bits required and how many characters maximum we can represent like this. So you can use this formula to do the number of bits. Okay, and all these are not doing encoding. This is also not. So this is all theoretical part. So let's move to the question. If any question we have related to this code segment. Okay, so this is related to the big 3. This is also big 3. This is also big 3. Yeah, this one is the. Okay. What is the range of value in sign int type variable can hold in a 32-bit architecture? Okay, so this is as a signed int. Okay, so here we can use the both type of representation for the sign int, and where we can use this that sign and magnitude, and also that 2s complement. Okay, so if we are using that sign magnitude, that is actually then we will get this 2 to the power 31. So you can see we have the 32 bit. So 1 bit we will use for the sign. Okay, and so we will get the representation like this 2 to the power 31 minus 1 on this side. Okay, positive side, and this side negative side we will get this minus 2 to the power 31. 31. Okay. Sign in that type variable can hold a 32-bit architecture. Minus 2 to 8. 51. So okay. Okay, so this is actually a range we can declare. So in the that signed bit, we can use this one less representation if we are using this, but in that 2s complement representation, we can use this one more range. So that means 2 to the power 31 to this negative range. This out. This is another option is correct. So one less that. Yeah, so this is actually a range calculated by the same both method, sign method and the 2s complement method. So you can just calculate this with the same with the help of that same range, which we have calculated by the 8-bit. So you will get this range.
So except third options, 1, 2, and 4 are same, right?
1 minus 231 and 231. Oh, both are same.
Three are same, sir.
Oh, second. Okay, okay. No, some brackets is different actually.
Oh, okay. Yes.
Okay. Yes, so you can see this is the round bracket, and this is a one that bracket and that one round bracket. So this bracket also
So,
contains some
yes, so third one is the right option, right? Because both the integers are included in square brackets.
Hmm. Okay, okay. So actually, in this, what happened if this bracket is actually used, this round bracket, so that is actually last value is not included in that. So if we are using square bracket, so that means both that corner value are included. Okay, but if we are using this square bracket, so that means left value is included, but right value is one more than that. So this is not included. So that means you will get a value only till this 2 to the power 31 minus 1 for this representation if you have one round bracket on this side. Okay, so this option third and fourth both are actually same representation. So this round bracket is just like a, if you have this representation, we are writing like 2 comma 5, so that means we have all included. Okay, so 2 3 4 5 like this, all included. But if we are writing 2 comma 5 like this, so that means this value is not included, we have only 2 3 and 4, this value will not be included, one less. And if you're writing like 2 comma 5, so that means value are coming in between only, so 3 4 like this. So in that question, uh, that question is actually this above one, you can see the range is 2 to the power 31 minus 1, so this is included here in the above option. But in the last option, this 2 to the power 31, and this is not included round bracket. So this question is asked in this mock, but this type of question generally we not ask because this is memory based things. This square bracket and round bracket, this is not too much logical. Okay, so but you can just remember these things. If we are representing any range and we are using square bracket, so square bracket means the range we are calculating including both the corner value. But round brackets means the range will come from in between without including these. Okay, so any side if you are getting this round bracket, so that means this is not included, one value before that, only that included in this range. Corner value is or the right side corner value is not included. So because of that, both options are actually same. Option third and option four are representing the same range. Because of that, this is correct. Sign int form.
Okay, sir.
So 10th, so all are now code based. But also practice this number conversion. Okay, so that number conversion is also important. So do not. Okay, number conversion is given in the last. Yeah, here. Okay. Consider a decimal number 108. What is the 8-bit binary representation of it? Okay, so 8-bit representation is asked. So 108 we can convert into the binary form by the division method. So 108. Okay, so just perform the division method and you will get a 5 4. Okay, so this set 0, then 27, 0, then again this is 1 and 3 and 1 this side, and 2, and then again 6 1, and then 2 3 0, then 2 1 1, and this side now 2 0 1. Just read this like so: 1 1 0 1 1 0 0. So how many bits are there? 1 2 3 4 5 6 7. But we need a 8-bit representation, so just put 1 0 before that. Okay, So now this is the equivalent binary number. So 0, 1, 1, 0, 1, 1, 0, 0. So you will get a numbers 0, 1, 1, this option 1, 1, 0, 1, 1, 0, 0. Yeah. So this is the correct answer. And last question, you can see the binary number is given and hexadecimal is asked. Okay. So copy this. So here you can take 4 4-bit. So you can take 4 4-bit. So we have 1 1 1 0 1 1 0 0 1 1 0 1 1. Okay. So always pick from the right. Okay. So we cannot put 0 after that. That will change the value actually. Okay. So but in binary we can put 0 before any number. So like 4-bit from this side. Okay. So this is the one combination. Then second. Then third. Now we have one left. Okay. So we can put 3 0 before that. Okay. So this is now equivalent to 1. This is equivalent to that 13. So that means A, B, C, D, E, F. Okay. So that 10, 11, 12, 13, 14, 15. So this is equivalent to 13. Uh, so after some practice, till just you can remember the binary equivalent value from 0 to that 15. Okay, so this is actually very helpful for sometimes you can directly write the solution. So in some practice you can remember this. Okay, so 0 is 0 0 0 0, like then 0 0 0 1 0 0 1 0. So this is the equivalent binary number in the decimal form. So you can use this. Okay, so this is D, and this 1001 is actually a 9, so we can write 9 as it is, and 1011 is actually a 11. Okay, so 11 is represented by B. So 1D 9B. So this is the hexadecimal equivalent 1D 9B. This one. Okay, so just practice on this number conversion little bit. So these are the requirement. Which of the following valid type of operator? So this is from big 3. Okay. So now this is big 3, and now let's move to big 3. So big 3 is basically starting of C programming, and we discussed the variables, keyword, data types, operator, expression, like these basic things. Okay, and operator precedence also. So in this basic structure is discussed. So we define some that preprocessor directive. So this is called as a when we write any program. So this is the basic starting syntax. So hash include stdio.h. So hash is just a preprocessor directive, and this is just a symbol that actually tells to the compiler that uh, before compiling any program, some pre-processing happen. So that is actually declared by this hash thing. So that means some operation will be performed before the compiling. So like this include stdio.h. So this is just another C file we have that actually contains lots of definition, predefined definition by the C, like standard input output, printf, scanf, this type of definition is defined inside this. So that actually program is included in our program when our program runs. So we are including this complete C file in our program, and we can define something. So like define py and this value. So that means instead of writing this value, we can directly write pi value in our program. So in our program, at any time if we return this pi, so that will be considered as a this 3.14159. Okay, so this is just a representation. Define py label to this value. Okay, at any time if we are writing this py value in our program code, so that will be deal as a this 3.14. So these are some operation. This is called as a preprocessor directive. We and macros. So these macros are discussed in detail in later week 11. Okay, but global declaration, some that variable we declared in the global area. That means in our program we have this type of structure mainly. Okay, so this is the main structure. And before that, Okay, this is the main list. So this is the main function. Actually, this is the identification of function. Function is just a block of code. Okay, and block of code means we have written our code inside this curly bracket with name function, this main function, and this function is executed by our compiler first. So that means the instruction which is written inside this will be executed one by one from this main function. And we can write another function, we can define another function like this main function, and then we can call this function from our main function by the name. So but these are actually the later topics. So now we are discussing the structure. So this is our main function which required in every program, and compiler looks always first this main function. Okay, and inside this we write our instructions sequence. Okay, and this is called as a return type. So what our function is returning, that what type of value, so that we return by the function that type of value. So uh, another things is statement and expression. You can see we are writing like this: statement x equal to 5. So that means we are assigning some value to this variable x, and this is called as a comment of the program which we are writing to help to understand the program. There are two types of comment: single line comments we can write like this with the help of double slash, and multiple line comments we like that the open, this is the open comment and this is the close comment. In between we can write multiple line. This is called as a multi-line comment. And return statement, if we have defined any return value to the function, that integer or things, so we need to return that type of value. Otherwise, so like this above function int main, we have defined the return type, so we have to return that type of value. If we don't want to return anything, so we have to define here void. So void means none. So that means we no need to return anything from the function. So that returns means this function will return some value to the same program. Okay, so this is called as a return, so that we will discuss in later week 5. So yeah, this is the basic structure, and this is the complete program you can see. So this is a preprocessor directive. This is we are including the library, and outside of the main function, that part is called as a global area. We can declare any variable in this area that can be accessed from any part of the program. We can access this variable value inside the main function, but we cannot call the any this local, this is called as a local variable. So if any variable is declared inside the function, that variable is a local for the function. Okay, but this is the global, so that can be accessed in any function, but the local variable cannot be accessed from another function. So this is called as a global variable declaration. This is another function declaration, and this is main. Inside the main function, if we are declaring any variable, that is called as a local variable. Okay, so that can be accessed inside the main function only, not outside the function. So you can see if we are writing this add global function, we are calling. So we are passing this add x global variable. So that function. So I'm not going deep, otherwise it will confuse that. So that function I am not explaining in detail. So okay. So this is the basic structure. These are the expression. Okay, and this is print statement return 0. And here we have many times declared that this is a variable. So what is the meaning of variable? What is the meaning of keyword? So keywords are a words which are actually predefined in the language, and they have the specific meaning in the language. Okay, so like in the syntax or that are predefined in the language actually. So like this auto, break, case, care, const, all these words are actually predefined in the language, and all these have some specific meaning in the program. So these are called as a keyword, and we cannot use these word as a name of our variable. Okay, so all these words are predefined, and after that variable, yeah, this is the important. So we have when we are writing any program, we need to store the data in our memory, but every memory is identified by the address. memory address, and that is just a some value in hexadecimal or the binary representation, and that is actually not readable properly, and we can also not remember that address. Okay, so we need to store that memory in some variable. So that variable is just called as a label. We just give some label to the memory address, and that label we can easily remember. We can give any name for that variable, so we can easily recall that. And so you can see variable are named storage location in computer memory that hold data. So suppose if any memory is assigned for to store one integer value, so like 10, and it contains some address like 101010058, like this type of address, but we cannot remember this address. But what we can do, we can just give a name, like this is a age. Okay, age. Okay, now when we are writing like this, int age equal to this value 10. Okay, so what happened, this address is actually linked to this age. Now everywhere we will use this age, and we can directly fetch this data. We no need to remember this address actually. Okay, so this age is just a label for the memory, and we can use this label to get the data from memory and compute the operation. So this is called as a variable. We can give any name for this label to store the data, and that we need to declare this variable, so the memory is linked to that. So variable declaration, before using a variable you must declare it, specifying its data type. So data type means what type of value we will store in this. Okay, so age, so we have to declare the data type integer, then we can only store the integer value on inside this. Okay, so data type and then variable name, like this, int age. But it has some rule. We cannot give any name. Okay, so it has some naming rule, you should follow these. We can include these three type of characters: letters, digit, and underscore. Okay, for giving naming this, and this they must start with a letter or underscore. That means any variable name we cannot start with a digit. Okay, so we cannot write like this to name. Okay, so this is a invalid variable. Okay, variable can be start like this, name underscore. Okay, name. We can use digit later in between, like 2 underscore, like this, but we cannot start any name with digit. Okay, and we can only use letters, digit, and underscore. So these are important. And C has reserved keywords which we cannot use. Okay, and also it is case sensitive. So that means if we are declaring int a equal to 10 or int a equal to 10, 20, so both are actually different variable, not same. If any small and capital value is there for the name, so that is actually different. Because of that, this is case sensitive. So this naming is important for some questions. So this type of question is also asked: which one is the valid variable? Okay. So one another symbol is also now included in this, and many compilers actually support that. That is actually a that this dollar. Yeah, dollar. This actually operator is also supported by many compilers, but it is not giving any documentation. Okay, so otherwise just follow this rule to validate any answer. After that, data types, so that represent which type of value we will store, and it represent the types of the data. Okay, so in C we generally use these type of data: integer. Integer means the whole number, positive, negative, or 0. Okay, so integer value mostly take 4 bytes in the memory. Okay, and this is the representation int for the integer. And another type of data is float to represent floating point. We have like this 10.5, 20.56, like this type of value we have. So we use the data type float. Okay, it used to represent the decimal number with single precision. So single precision means it has some range after the decimal point. So we cannot store like this after decimal value. We cannot store like 20 digits. So it's have some range like up to 6 digit. Okay, it will give the correct answer. After that, it will not store properly. Okay, so 4 byte it takes. If we want to store more digit in the decimal part, that after floating point, so we use this double. So this is actually a double precision. So that means it can contain more digit after the decimal point. You can see. Okay, so this generally take 8 bytes to store this. Char or sometimes is a integer. Okay, so that is called this sort smallest integer value. So char, it takes 1 byte only. Okay, so it store the single character, uh, and like we can store the character in the single quote. Accurate. Okay, and this is not very common, but some we have to include some library for that. Otherwise, we generally use 0 for false and 1 for true. This value. Okay, otherwise we no need to declare this is specifically in our program. So you can explore this. Void means absence of the value. This is also important. Voice means absence of the value. So like, suppose if you don't want to return any value from the function, so you can write void. No need to return anything. Some custom type data, this will discuss later, so that is not important. So another is sort is also the sort integers for 2 byte only. It takes 2 byte. It have some range. 2 byte means total 16 bit. And this is signed and another forms of the data. Apart from that, we have the operators. So what type of operators he supports? So plus, minus, into, division, remainder, modulo. Okay, so these are the arithmetic operators. And after that, relational operators. So relational operator means to compare the value, and this is used inside the condition. And our condition always return true or false. Either condition will be true or false. So that means if we want to check the comparison like equal to, if both A is equal to B, okay, we are checking both value are equal or not. So that means true or false. If not equal to, so A is not equal to B. If this is not equal to, then it will return it true. If it is equal, then it will return it false. Less than, if to compare the value in less than, greater than, less than, equal to, greater than, all these are actually the comparison operator and relational operator used inside the conditional statement. This is a logical operator. This is very important. This AND operator, or operator and not operator, this actually used between the condition. If we want to combine more than one condition, so we use this AND operator. Suppose we are writing like condition if A equal to B. Okay, okay, and another condition we have like C equal to greater than D. Okay, suppose we have these variable A, B, C, D, and we want to check if both conditions are true, then we will perform some things. Okay, so we will use AND operator. Okay, if we want to check if our both condition is true, then we will perform some tasks, otherwise not. If any condition is false, then we will not do anything. So then we will use AND operator. AND means both conditions should be true, then output will be overall true for this expression. And OR operator means if we are using OR operator in between, so that means if any condition is true, then overall output will be true. So, and this is for not. That means if we are checking any condition and we can convert the output in, if we are getting true, then we will convert into a false. So it will change. Okay. But there is one important thing inside this.
Sir,
Yes.
sir, can you explain logical operators with the example?
So logical example. So I'm taking 1 second. So suppose we have value A equal to 10 and B equal to 20 and C equal to like 5. We have some variable of all our integer types, and we are checking that if our that a and b both are actually a even value. Okay, so how we will write this condition to check? We are getting some value in a, b, c, and we want to check if our a and b both are even value. Then we will print some message. Otherwise, we will print our a and b are not even, like this. Okay. So how we will write this condition? So we will write like this: if a percentile 2 equal to 0 and b percentile 2 equal to 0, then we will print that both a and b are even. Okay, so else,
Sir, in the same program, if we put or, what will happen?
so what will happen? So regarding this, if we are getting a equal to 10, b equal to 20, okay, then this message will be print. Okay, and if we are
So,
passing a equal to 10 and b equal to 5, okay, to this program, then this message will not be print, because only one condition is true, second condition is not true. So in this AND operation, if we have two conditions, so I am just writing this like this. So C condition 1 and condition 2. Okay, and we are using AND operator. So what happened? Operation C1 and C2 I am writing here, and this is the AND. So if C1 condition is true and C1 is false, okay, so overall result will be false if we are using AND operation. If C1 condition is false, C2 is also false, overall will be false. If C1 is false, C2 is true, then still output will be false. If both conditions are true,
so
then
for
output will
AND
be true.
operator, we need to have both conditions true. For
Yes.
OR operator, it can be true or false.
So this is for AND. Just tell you C1 and C2, and operator is now C1 or C2. Okay. In this operator, if any of the condition is true, output will be true overall. So suppose if both are false, then output will be false. Otherwise, if any is true, then output will be true. Right.
So in the statement, if a percentage 2 is equal to 0, and then if b percentage 2 is equal to 0, lastly it must be like equal to 0, right?
Equal to this is a comparison operator. That means we are
No,
checking.
sir.
Uh-huh.
After that, sir, like after that, shouldn't be like equal to 0, then print both are even.
No, I'm not getting your query. So what you are saying? Can you repeat?
So yes, sir, see, we have C1 and C2. We have given two conditions. After that, we at the end we have to add like is equal to 0. Then print statement must come, right?
No, this C1, I am writing this complete condition as a C1. Okay, and this complete condition as a C2, like this.
Yes, sir. The condition is true. We have to print this, or false. We have to print this. That we have to mention, right?
So here actually, if this left side value is matched with the right side value, so this overall condition will become a true. This side, if this is just an expression, we will get some output for this expression, and if that output is matched with the right side value, so this condition will become a true. Then we will get this type of table. If both true, then this statement will print. If any of the condition is false, so if you see this, if we pass the input a equal to 10 and b equal to 5, so 10 percentile 2, you are getting 0 reminder, correct? So this become a true. 5 percentile 2, this will actually will return a 1 reminder. So that means 1 is not 1 equal to 0. So this condition is not true, because this side is 1, this side is 0, not both are not equal. So this expression will return a false result. Okay, so what comparison operator we are using? Based on that, our condition will return true or false. So here we are checking the equality on the left or right side. If we are getting equal value on the right or left, then we will get the true answer, otherwise false. And if our both condition are now become true, then overall result will be the true for this complete expression. Okay, then we will enter inside this block according to the if. So if our condition, overall condition is returning true, then we will enter inside this block and this print statement will perform. Okay, otherwise this part will not be performed and we will move to the else part if we have any else part.
Sir, the same statement, if I have a percentage 2 equal to 0 and a b percentage 2 equal to 0, if I take a new variable, c is already given as 5, sir. So if I put or c percentage 2 equal to 0, what?
Okay, so that you are saying three condition.
Yes, three condition with c.
So C1 you are taking like this and C2 and like taking or
Or
C3.
c3, yes, sir.
Yeah, you are saying three condition we have. So if we have chaining expression, so like this is called as a chaining expression where we have more than two condition. So first this condition will be checked. Okay, what is the overall output of this condition? If we are getting overall this condition is it true, then this means this part become a true before or that. So that means now overall output will become a true, because in the or condition, if any condition is true, so output will be true. If this is false, then compiler will check this C3 condition. If this is a true, then overall will become a true. If this is again false, then overall will become a false. Okay, so that means condition will be checked in two pair. So first it will be checked what is the overall output for this, then that output will be compared with the this operator. That will be checked with this operator. Okay.
Okay, sir, understood. So first and operator, after that or operator.
So left to right. This is called as a associativity.
Okay, sir.
Okay. If we have multiple operator, then which operator will be performed first? So we have
Sir,
this.
is there any preference order like?
So this is called as a preference. This is sometimes called as a associativity also. Operator precedence or operator associativity.
Okay, sir, understood.
Okay, so if so that we are discussing next. Okay, so this is a logical operator. Yeah, sometimes some tricky question asked like this. Okay, so what question is, yeah, pre-increment, post-increment, these operator is also there. So let me discuss first that. Okay, so this is called as a assignment operator. So assignment means we are assigning something. So that means if we are writing a equal to b. Okay, so what is the meaning of this? So the value of b. So this right side we always call as a value of b will be assigned to this location, to a. Okay, if our b equal to 20 declared before this, so that 20 value will be assigned to this a. So a will also become a 20. Okay, if assignment operator means the value of the right side variable will be assigned to the left side location. If we are writing a equal to 20 directly, so that means 20 is the value is assigned to this location a. Okay, so this is assignment operator. This is the another form of assignment. So what is the meaning of plus equal to? So if we are writing a plus equal to 2, okay, and initially we have a equal to 10, suppose. So what is the meaning of this? This is the equivalent of a equal to a plus 2. Okay, now this side we will read the previous value. So what is the previous value? 10, and 10 plus 2 is now become 12, and 12 will be assigned to this a. So a value will be updated by 12. Okay, so this is the equivalent form of this. So plus equal to means a equal to a plus 2. A minus equal to means that means a equal to a minus 2, like this. Okay, so we can write like this, and same into that a into equal to 2 means a equal to a into 2. A division equal to 2 is a equal to a divided by 2. Okay, same modulo. So a, this remainder equal to 2 means a equal to a remainder 2. So this is the operator that all are actually called as a assignment operator. Okay, now increment and decrement operator. So This is called as a increment by one value or decrement by one value. So we can write like this. So if we have a equal to 10, okay, initially, now we can simply write a plus plus. So what is the meaning of this? This meaning is a equal to a plus 1. Okay.
So A has become 11, sir.
A will become 11. So what is the value, current value of a? 10. 10 plus 1, 11. So 11, this will be updated to 11. A will become 11. And when we are writing a minus minus, so that means a equal to a
So
minus 1.
instead of this, we can also write A plus equal to 1.
Ha
Everything.
ha ha. Yes, you
Ah,
can write. Okay, so this is the equivalent things. A plus plus,
understood.
this is the short form to of this a equal to a plus 1. That means we are incrementing the current value of a by 1. This is, we are decrementing the current value of a by 1. So this is the that increment and decrement operator. And similar operator we have this pre-increment and post-increment. Okay, so this looks like very similar, but if we are writing this pre-increment and post-increment in this single expression, okay, so this we are writing like this a plus plus. This is single expression. So this is work like this: a equal to a plus 1. But pre-increment and post-increment is also performed with the variable. This is not performed with any direct value. Okay, this is performed with this is also same increment by one operator, but here this is the term pre and post. So you can see this plus plus operator is coming before the variable name, this time coming after the variable. So what is the meaning of this pre-increment and post-increment? So we generally like this pre-increment and post-increment operation within some expression. Okay, and we have multiple operation in the expression. Suppose in this example, if you can see, so we have x equal to 5 predefined, pre-initialized. Now we are writing y equal to plus plus x. Okay, so this is a expression. Inside this, we are using this operator pre-increment. Okay, and pre-increment means, according to this name, pre-increment. So here two operations are there. There is one operation pre-increment, another is assignment operations. We are also performing assignment operation. So before solving the expression, we will perform the increment first. Okay, before solving the expression, we will perform the increment. So this is called as a pre-increment. That means we will perform this increment first, then we will use the updated value into the expression. Okay, so here what is the current value of 5? 5 will be incremented by 1. That will operation will be performed first. Okay, so that means x will become a 6. Okay, then that 6 value will be assigned to y. So this y will become a 6, and x is also incremented, so x will also updated by 6. So after this operation, you will get a both x is now 6 and y is now 6. So that means before using the expression, that update, that increment the value first. Okay, and another type is post increment. So that means first use the current value of this variable in the expression and then increment this variable. Okay, post means we will use the current value, then we will update the increment this value. So the same syntax you can see here now: x equal to 5, and now we are writing y equal to x plus plus. So this is a post increment. Okay, so that means first we will perform this expression. So what is the current value of x is 5. Now we will use this y
Y is
equal
6.
to 5. Okay, after performing this operation, assignment operation, then we will increment this x plus plus. Okay, so now x will become a 6. So our output will be y equal to 5 and x equal to 6. X equal to 6, y equal to 5. So post increment means increment operation will be performed after solving the expression. Okay, pre-increment means before solving the expression, we will increment the value first, then we will use the value in expression. So this is important points about this pre-increment and post-increment. And related to that, some type of question are asked in the exams with the using of this and or operator. So one important thing is, suppose we have one this value a equal to 2, b equal to 5. Okay, and we have the expression like this: if a that plus plus equal to 2, okay, and that b that minus minus, okay, equal to 4. Sorry, this is equal to comparison operator. Suppose this condition is there, okay, or what we can do, we can without this if, we are writing like this. So z equal to or c equal to int c equal to, this expression is written like this: a plus plus equal to 2, okay, and minus minus b equal to 4. So like this expression is written, what will be the value of c, okay. So that means this is the conditional statement, and if value is true, you will get a 0, that one value. If value is 0, that means false. So this condition, now just tell us the first condition. This is the c1 and this is c2, and we are checking this. So what will be the output for this condition? Here we are comparing two value.
So is it 0?
No, just tell me the first condition,
No.
c1 0. You are saying false.
So if b minus minus b is equal to, is it 4 or 9, sir, for in c?
No, just tell me c1 first. C1 is false and true.
C1 is true.
True. Or c2?
So oh, it's even true. So answer will be 1.
Yes. So here you can see a plus plus. So a plus plus means current value of a is 2. And this is post increment. That means first we will compare the value, then we will perform the post increment. Okay. So that means current value is 2. 2 is equal to 2. Yes, means true. Okay. Condition is true. And C1 will become true. This case. Okay. But a value will be updated by 3 after this operation. Okay. And this is the second condition, minus minus b. So this is pre-increment operation. So that means what is the value of pre? Is this, sorry, this decrement operation, pre-decrement. So this is 5. First thing, we will decrement the value. So that means value will be decrement by 1. So it will become 4, and then 4 equal to 4. This is also true. Okay. So both conditions are true. Then you will get a c equal to 1. But what will the value of a is now 3, and b is also updated with 4, one less value. So these are the updated value by this condition. Now the important concept is here. Suppose suppose if I write this like as a 3, okay. Now just tell me what will be the value of c, a, and b. This is the one important things. So here we are checking a plus plus. So same things, we are getting 2 value, and this is post increment. Now 2 is not matched with 3. So this condition is false. Correct? 0. And now a become 3. So if we are using AND operator, if first condition is now become false, so there is no need to check second condition, because AND operator said that if any condition is false, output will be false. So compiler also skip the second condition if it found the first condition false. So that means if this condition is checked and this condition is false, and we are using AND operator, so that means compiler will ignore the second part completely without checking or executing anything. So in this case, with AND operator, if first condition is false, second condition will not be checked. So that means this operation will also be not performed, decrement operation. So this part will completely ignored by the compiler, and overall output will become a 0. So that means you will get a c equal to 0, c, this b, and a value will also updated 3, but this will not be updated. This part will be ignored completely. So this b will remain 5. Okay. So just remember these things. In the AND case, if first condition found false, second part is not evaluated. So any operation is happening in the second part, that will not be performed. Okay, and same case is the in the or case. So if you have like this int c equal to a plus plus that equal to 2. Okay, same condition. Now I'm using or, and minus minus b equal to 4, this second condition. Now in or case, according to the or case, if any condition is true, output will be true. So that means if compiler find this condition true, compiler will not check second condition. So this part will be ignored. If first condition is false, then compiler will check the second condition. This okay, in the or case. So same things. If here the value will be if this condition is true. Okay, this is true according to the our input. Now C will become 1, this A will become 3, and this part will be ignored. Doesn't matter if it is true or false, because first is true, our overall output will be true. So this part will be ignored by the compiler. Okay, so now B will remain 5. So just remember this two important point. In the end case, if first condition is false, overall output will be false, second condition will not be checked. If first condition is true, then second condition will be checked. Okay, and in or case, if first condition first condition is true, that means overall output will be true. Okay, second condition will not be checked. If first condition is false, then compiler will check the second condition. So if any operation is happening in the second condition, so just remember this, check that what is the operator, and what if we are getting first condition true or false, according to that. And in the case of end, second will be execute or not. So just remember these 2 points. These are important for the exam purpose with this pre-increment and end operators. Okay, so this is the first thing. And then after that, operator precedence. So we have mentioned this common precedence, like this is the highest precedence we have in the expression brackets. Yeah, someone mic is on, please turn off. Okay. So parenthesis is the highest precedence to solve. Then unary operators. So unary operator is just like a pre-increment, post-increment, and this plus sign. Suppose you have the variable a equal to 10, and like you are writing like b equal to minus a. So this is a unary operator that performs with single value. So minus. Okay, it will make a negative this value. So this is the second highest. Then multiplication and division, all these have the equal weightage, actually equal that precedence. Okay, if you have the expression like this 5 multiply 3 division 2. Okay, so this expression, actually all operators have the same precedence. So in this case, we check the associativity. If any operator have the same precedence, then which operator will be solved first? So in this case, this expression will be solved left to right. Okay, here this multiplication, division, modulo, all these have the same precedence. If any expression can contains all these operators only, so in this case, expression will be executed solved left to right manner. Okay, left to right. This is called as a associativity. In this case, same addition and subtraction have the same precedence. So if expression is written like 2 plus 3 minus 1 plus 4 plus minus 3, like this expression, here plus minus all are the same operator, and both have the same precedence. In this case, this will be solved left to right manner. Okay, this is the associativity, left to right. Okay, now this relational operators, all these have the same precedence. Equality operator, this comparison operator, the logical and this is the order of the precedence to solve. And now then associativity, as I mentioned that. So most of the operators we have left to right associativity, like arithmetic operators. So this plus, minus, multiplication, division. So all these comes have the equal precedence. These comes under the equal precedence. If you are getting this type of operator sequence, left to right will be solved. Okay, and there is one equal sign, that it contains the right to left associativity reverse. Like if you have value a equal to b equal to c equal to d equal to 10. So how this expression will be solved? So here all are equal sign. So here actually this will be performed from right to left. First thing, this part will be solved. So this 10 will be assigned to this d. Okay. Now the value of d will be assigned to c. Then value of c will be assigned to b. Then value of b will be assigned to a. So this expression will be solved from right to left manner. Okay. So this equal operator actually have the right to left associativity. Okay. Otherwise, this conditional logical operator, we have seen that this is also a left to right. You can see this condition. So a and b or c. So left to right. First, this condition will be solved, then or condition will be solved. Okay, so this is called as a associativity. Apart from that, so this is all about operator, variable, all these things. So now this input output scanf, this we used in the basic program. Now this is completed, and let's do the questions related to this. Now sixth question you can see. So okay, I am just copying these questions and we'll solve one by one. Okay, so this is so this is the first question we have. You can see a equal to 1, b equal to 1, and x is not declared. So now we have a plus equal to b. So a plus equal to b. So what is the meaning of this? A equal to a plus b. Okay. So now what will be the value of a? So you can see 1 and plus 1, 2. So a will become 2. So this is the updated value. We will always use this updated value in the upcoming expression. Okay. Now, so this is the current value of b, and now this is the updated value. And next expression is x equal to minus a plus plus. Okay. And then plus, and this is plus plus b. So yeah, this is the expression. Now just solve this, how this will be solved. So you can see a is incremented here in the previous step 2. Now what will be the value of x now? Okay, so this is post increment. Okay, this is post increment. That means first we will solve this expression. So this is now minus a. Minus a means minus 2. And plus, this is pre-increment. So pre-increment means this plus plus b. So b is now 1, so that it will become a 2. And 2 and minus 2 now become a 0. X equal to 0.
Sir, one doubt.
Yes.
It is given minus a plus plus. So minus a plus 1, sir.
No. This is a post increment. Okay. This is a post increment. So post increment means this increment will be performed after solving the expression. Okay. First, we will use the current value of a in the expression to solve. Then we will increment the value of a.
Yes, sir. Current value of a is 2. So increment means 2 plus minus 2 plus 1, sir.
So we are not incrementing before solving the expression. After that, we will increment. Post increment. No. What is the meaning of post increment? If we have written this x equal to minus a plus plus, okay, and plus this is pre-increment b. So post increment operation means this is the expression, complete expression. We will increment this value of a after using the current value of a in the expression. Post increment means we will increment this a value after using this current value of a in the expression. So that is called as a post increment. Pre increment means first we will increment the value of b, then we will use this value, updated value of b in the expression. This is the post increment as we have discussed previously. So if suppose we have a equal to 10 and we are writing this b equal to a plus plus. So what will be the value of v in this expression and then a? So here,
11.
no, no. So here this is post increment. Post increment means first we will use this current value of a to this expression. Then we will increment the a. Okay. So that means first b equal to a operation will be performed, and after that a plus plus will be performed. This is a post increment operation. Okay. And
So what's the output?
so in this case, first we will use the current value of a. What is the current value of a? 2. So that will become minus 2. Okay. And this is the pre-increment. So pre-increment means first we will increment the value of p. Okay. So that means 1, that v plus 1. So that become 2. And then we will solve this expression. And after that we will increment our a value. So a equal to a plus 1. So then a value will become equal to 2 plus, that 2 plus 1, 3. Okay.
Oh, okay, sir. Okay, sir. Understood.
Okay.
I thought
Now,
we should, sir.
yes.
I thought we should only increment, and after that we should solve.
No, no, no. So post increment, we will use the current value first, then we will update only the value of a after this expression. Okay. Here we will increment first, then use.
Final value of a is 3 and b is
Huh.
2.
B will also be 2, but x is now 0. And we are printing the value of x in our code.
So final value of x will be 1, right, sir?
No, 0.
So we are not incrementing since minus 2 is.
So minus 2 and this b is incremented by 1. So b was 1 actually. So this is incremented to 1. So minus 2 plus 2, 0.
So we are skipping the increment for minus 2.
This is post increment. Na? So post increment
Okay,
means this increment will be performed after the expression. Okay. So this calculation is now giving us to x equal to 0. So that 0 x we are printing in the output. So output will be 0 for this person.
Sir, I have another.
Haha.
Sir, should we mention that x equal to int in the first step? Int of x you have given. First step.
Yes. So, yeah, this is integer, na?
Yes, sir. Is it necessary? Or can we directly put x as a variable and write?
No, no, no. If you want to use any variable, you have to declare first. You cannot directly use the x variable directly here. So
Okay.
this expression is actually we are writing. So this int is the data type for all a and then b also, then x also. Okay, so this is the declaration for all. That means a, b, x all are integer variables. And you cannot use directly, like without declaring any variable, you cannot use in any expression. That will give the error actually in the code. Okay, so the output for this code is actually that
Okay, sir.
0.
Understood, sir.
And let's move to, we have this. Okay, so which of the following is are not valid data type in C language? Okay, so as we have seen this, integer is a valid data type, char is a valid data type. Okay, but string is actually, there is no data type in C. Okay, so string is not a valid, and class is also not a variable data valid data type. Okay,
Okay,
so
sir.
that means correct answer is string and
String and
class.
class.
Yes. Okay. And next expression, yeah, this we have discussed. Okay, so this type of conditional things.
Sir, will there be revision class like this for all other subjects?
Have you received any communication regarding that?
No,
Any?
sir. No, sir.
No, I'm not sure, but they were planning actually. I'm not sure. I'll check this. Okay, after
Okay,
this.
sir.
So for physics, we will be having probably on Saturday. If, is it possible? Could you ask for maths tomorrow? Like whom to ask you?
Okay, I'll check this. I'll just convey your message to them. Okay, so maybe they will arrange.
Thank you so much, sir.
Okay. Yeah, so this question we have already seen that here what is given, for which of the following integer value x and y the given code snippet prints 0. Okay, so what we are doing, we have this expression, so x is greater than equal to y, and okay, this is the end condition, and second condition is x is divided by y equal to 2. Okay, So this operator actually, if we are performing this division operator between two integer, okay, so suppose if you are writing 10 divide 5, so what this operator actually will return, because this operation is performed with integer, so no, this is not correct. Suppose this is 4, okay, generally you will get 2.5 input, correct? For to the 8 and then yeah 5. Hmm. But in this case, if this operation is performed with integers, so you will get only integer part for this calculations. Okay, only 2. That float part will be lost actually in this calculation, because this division operation should be performed with float value. Then you will get a correct answer. So in this case, we will. So this question can be solved with the help of option. Actually, we need option also, because here this question is asking from the option only. So 1 second. Let me copy the option also. Okay, so just check. You can check here AND operator we are using. Okay, so if first condition is false, no need to check second condition. So this is the things, and we are checking zero output, means false condition overall. So here x 15 y 5. So yeah, 15 is greater than equal to y. Yeah, this is true. Okay, now we will check this. So 15 divide 5. So we will get 3. Okay, so 3 is equal to 2. This is false. Overall will be false for this. Okay, the second condition is false. For this one, again 10 is greater than equal to 5. Yeah, this is correct. But we are getting 10 divide 5 equal to 2. So this condition become true. Okay. So here this condition, first condition is false. So 5 is not greater than equal to 10. So this condition is false. Overall is now false. No need to check second condition. 20 is greater than 10. Yes. Okay. So this is true. And 20 divided by 10, 2. Yeah, this is also true. Okay. So this is also true. And 10 is greater than equal to 10. Yeah, equal is there. So this is first condition is true. But 10 divided by 10 is 1. So this is not, second condition is not true. So then overall is false. So you need to just put this input and check if both conditions are true, then output will be true, otherwise false. So this, for this answer 0 means these are the correct option, first, third and fifth. Okay, so 0 means false. So first, third, these are the correct answer for this. Okay, so this is one ternary operator. Okay, so that is also a conditional statement.
Sir, this question only I can't understand. The question marks are all coming in between.
So this is actually conditional statement and comes under as it operator, ternary operator we call this. So I'll just explain you what is this.
Okay.
So this is 9th question. So what is this first thing, operator? So what is the operator meaning is, so this x equal to this question mark this and this. So this is called as a ternary operator. So what we generally write like this, I'm writing this like what we can write. So x, suppose I'm writing the short form. So if x percentile 2 equal to 0, okay, we are checking this condition, and question mark. Okay, so this condition we are checking after, in the first part, after this first question part. So that means, suppose we are printing print, if this condition is true, then this print number we are writing even. Okay, else, after this colon, else part. Okay, print odd. So this is the condition we are checking. If this condition return true, then this part will be performed. Okay, this part will be performed after question mark. Okay, this part will be performed when this condition is true. If this condition is false, then this part will be performed after colon. Okay, so this is called as a ternary operator, conditional operator. This is equivalent to conditional operator. So we are checking condition first. If condition is true, then after question mark we have written what statement we have written, that will be performed. If condition is false, then this part will be performed. Okay, so here what we will get the overall output here. Okay, so x equal to 8, y equal to 3. So now we are writing int x equal to, okay, now just check this condition. This is the condition. So x reminder, this the reminder operator y. So that means we are dividing this 8 percentile y. Okay, so that means 3, and this does not equal to 0. So you can see when we are dividing 8 by 3, we are getting remainder 2. Correct? So 2 is does not equal to 0. Correct? So this condition is now true, because according to the condition, if both value are not equal to, so if this condition is now become it satisfied, so that means our output is true. And in true case, just follow this operation. So that means our this operation will be performed. So x reminded y. So that means 8 divided by 2, 3. And what is the output of this expression is 2, reminder value. So that 2 value will be the output for this. Okay, if this condition is true, this is the summary.
So won't it be in decimal points? Because
No, we will not. So decimal point means
so like 2.66 because
no. This
it
is
will give
a.
float
This is
value.
not a. This is not a division operation. This x percentile y. This is not a division operation. This is a reminder modulo operation. What
Oh,
reminder
okay.
we
So I
will get?
just got
Oh,
confused.
okay.
Okay.
Also, if you are for performing this x divide y and both are integer value, still you will get only integer part of the division. Okay, decimal part will be ignored in this case. If you are performing this division operation with the integer value, then 8 division 3, you will get only 2. This is not a reminder. This is 3 to just 6, so that 2 only. Okay, so this you will not get 2.666. Okay, so this part will be lost actually in this case.
Okay, sir.
Okay, if you are using this 8.0 divide by 3.0, then you will get a 2.66.
Okay, sir.
Okay, so in this case, what we are getting 2 as a output, and that 2 value will be assigned to x. Now x becoming 2. Okay, so this will be the output. X equal to 2 is the answer for this. Clear? If the first condition is false, then perform this operation. Second.
Sir, can you explain the question mark part again?
Question mark part. Okay.
Yes, sir.
So in this expression, this x equal to this x percentile y does not equal to 0. This and this question mark and this expression x remainder y and colon x division y. So this is actually a one single operator called as a ternary operator, and this operator means this part, first part before question mark, this is a condition. Okay, we are checking this condition. If this condition is a true, okay, output of this condition is true, then we will perform this expression. Okay, this condition, if our output is true for this condition. If our output is false, then we will perform this part.
Okay, sir, understood, sir.
Okay, this is the single operator, ternary operator called, and corresponding to this expression result, that will be assigned to this x. If this part is executed, what is the output
Okay.
of this? That will be x. Otherwise, this part will be assigned to x.
Okay, sir, understood, sir. It's like executing if and else, sir.
Yeah, this is similar to your if or else things. Okay. So this is done. Now this we have discussed. Yeah, this question. Okay, this is now conditional statement. Okay, and loop statement. Now let's cover to this also. Week 4. So week 4 is basically conditional statement. We have this control statement we called as, that means we are controlling the flow of execution. So we have two types of how we can control this flow of execution with the help of if statement or loop. We have two types of control that operations. So if statement, you can see this diagram. We have this structure. We check the condition, and based on the condition, our output will be true or false. So if our condition is true, then we will perform this body of if. Otherwise, we will exit the block. So this statement, we are using only condition check, and we are not using else statement. So that means this is the syntax for this. If this we are writing the condition inside the bracket. If this condition is written true, then we will enter inside this block and we will execute this. If our condition is false, then we will directly jump to outside of this, okay, without executing the inner part. And same, you can see the example for this. If x value is given 10 and our condition is x is greater than 5, this condition is not true, then we will enter inside this. If now x equal to 1, then it will become false, and then we will directly jump out. Okay, so this is a single if statement, and we can use if and else combination. Okay, so if condition we are checking, if condition is false, then we will use the another block inside the else part. So this is the structure. So we have two blocks, if block and else block. Okay, if the condition is true, then this part will execute, otherwise this part will be execute, and after that we will exit. So this is the structure. Okay, if condition is true, then we will enter inside this. If condition is false, then we will directly enter inside this else block to execute. Okay, and you can see this statement x equal to 3. So this is not true, then we will directly print this not greater than 5. Okay, and we can also use the chain. If else, if we have more than two condition, that means to check, then we can use this kind of chaining if else. So this is looked like this. If condition 1, here we have more than one condition. So if condition 1 is true, then we will enter inside this. If this is false, then we will check the another condition, else part, else if, then this condition. If this condition is true, then we will enter inside this. If this condition is false, then we will jump to next else if. If we have any other else if, then we will move to this. Okay, so in this way we are moving. If first condition is true, then we will only move to inside this, and complete remaining part will be skipped. Okay, if any of the block is executed in this, remaining block will not be checked. Okay, not be executed after that. So this is the conditional statement we have in C. So you can see this example, like if we are checking here this first condition, if this is not true, then we will check the second. If this is also not true, then we will check this else part. Okay, so this else is the last part. So in that syntax, you can skip this part. You can write your if block alone, okay, without else part. In the first statement like this. Okay, without else part you can write if, and you can also write if or else if. Okay, without else. So that means else part is optional. You can write your block, this if else block, without else. But if you are using if else if, you can use, but else part you can skip. But you cannot write without this if. This is the first statement you need to write. You cannot start like this, else if, else if, else. Okay, so that is required. Okay, but this last else is actually optional. You can write your code without this. So this is the one thing, else if. And similar, we have switch statement. That is also another version of conditional statement. So this is the structure of switch. Let me share you the syntax. Switch, and this is the expression. This is the keyword switch, and this is the expression we passed inside this. This may be a like single variable a or b, or like a equal to b plus c, like this type of expression it may be. So what overall output we are getting for the expression, that will be passed to the inside block. Okay, and that value, based on that value, we have decided that case. So this is also a keyword, case and value 1. Okay, and case value 2, case value 3, like this we can define the different condition. And we, at the time of writing the switch statement, we also ensure that what type of output we will get from this expression. So based on that, we have to define the case value. So the output value of this expression should be matched with any case, this value. Okay. If output of this expression is 1, then this is also written as case 1. So that is matched. Okay. So the value of this expression will be matched with any case value. That case will part will be executed. Okay, only. And if our case is not matched, then default part will be executed. So this is the syntax. You can see switch day. Okay, and we are passing day equal to 2. So now this 2 is not matched with this case 1. Okay, so this is 1 not matched, not equal to 2. Now jump to next case. Now this is 2. Yeah, this is matched with this 2 day value 2, and this part will be executed. Okay, print. And after that we have break statement. So this break is required in switch statement. Otherwise, if you skip this break statement, what will happen? After matching the case, all remaining part will be executed. So suppose if you not put this break, so that next part will be also be print. This will also be print. So break is the required things if you want to execute only one block, one case. Okay, but sometimes suppose if you want to execute the remaining part after the matching first. Okay, so this case 2 is matched, you want to execute all the remaining case after that. So at that time you can skip this break and remaining part all will be printed. So that sometimes it is useful also. Okay, otherwise just keep this thing in mind. Break is required in the switch case to stop only that case, otherwise the remaining part will also execute. Okay, so like this block diagram. So expression output is coming first. If case value is not matched with
Sir,
this, yes.
sir, can I explain switch statement with an example?
So this is the example now. Switch. Okay, so 1 second. This is the example we have. Okay, suppose we want to print the day name by the number. Suppose day 1 is the Monday, day 2 is the Tuesday, like this. Okay, and here we are passing the value of day, like we are passing 1, so Monday should be print. If we are passing 2, only Tuesday should be print. So that means day, we are giving the input day number, and the day actually name is printing. So this is also working like as a conditional statement. If our day value is matched with this case value, so that will be actually performed, that part will be performed. Okay, so here day we are passing 2, so the switch this part actually will pass as a 2 value, and this 2 is matched with this case, this value. So that means this part will be executed only, and you will get a output Tuesday. So any conditional statement you can write in this form also. If you have know that what type of output will be possible, okay, for the condition.
Sir, can we take an input from the user and do
Ha, ha.
like this?
So that type we can do. Let me just open this 1 second. Okay, so this is the basic program. We are just writing like this as a day, and okay, so inside this we are reading this from the user, so day, and after that we can use this switch statement. Okay, so like switch, and inside this we are passing day, and then we will use the case, so case like 1, and this colon, and after that we can write the statement like print f Monday, and then this statement, and then we can use break, and then case 2, okay, like this. So now we can copy the same part, Tuesday, okay, case 2 Tuesday. So in this, like, we can write any number of case. So let me just write all the remaining part. So last part, we will write as a default. Otherwise, case 3, case 4, case 5, case 6, case 7, and default. Okay. So default
Sir,
is just a invalid input.
sir, in exam will they ask like write the full code of
No,
approval?
no, 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 no. Coding writing is not the, not will come in the this exam. Okay.
The
When you
period
enrolled,
assignment was given.
only this theory type of assignments, that question will become. Okay. You no need to write the
Like
code.
find the output like that.
Code will be given, some output is asked like this.
Ah, okay, sir.
Okay. So this you can see now, Monday, Tuesday, I'm writing the sort. So where thur thur Thursday, and then Friday, and Saturday, and then Sunday. Okay. So if we pass any input here, so like we just write return statement. So this is for me. Okay. Now run the code. You can see we are passing any values like 4. So you can see Thursday. Only this part is executing. Is Thursday. What will happen if we remove this break? Okay, so you can see what will happen. And also use the slash n for new line, otherwise output will come in the single line. So let's run this and again pass 4. You can see what happening. So after matching 4 Thursday, all remaining are printing Friday, Saturday, Sunday, and invalid out. So this is one importance of the break here. So after entering into any case, after executing the statement, you need to break that to exit this switch. Otherwise, all remaining part will be case will be executed. Okay, so because of that, this break is required for switch if you want to execute only one case part. Okay, so that actually required. Okay, and suppose we pass, and we can skip this. And suppose we pass any random value like 114, you can see invalid input. By default, if any case is not matched, this part will be executed. So this is the statement we can use with the switch. Okay, so this is the switch. After that, we can also use this nested if else. So if under the another if like this, so one condition under the second condition. So you can see this inside this condition, if this condition is true, we are entering inside this, but another condition we are checking inside this. So this is called as a nested, one inside another. So that is called as a nested if else. So we can also write the code in this manner. And after that we have loop. So loop is also important. So this for loop we will discuss first. So for loop, what is the structure of the execution of for loop? So for loop means first part of the structure is initialization. We set some variable to some value, and we also give some condition to actually to check every time, every iteration. If this condition is true, then we will enter inside the loop block body. Otherwise, we will and coming outside of the loop directly if this condition is not satisfied. Okay, if this condition is true, we are entering inside the body. After that, we are updating our variable, loop variable. Okay, so in this way, this cycle is now running. So this initialization happened one time. This condition checks every time after that, and this statement will execute if the condition is true. After that, we will update our variable. So at after some iteration, this condition should be become false to coming outside of this loop. Otherwise, our loop will run infinitely. So this is the requirement things, and this is the syntax. Okay. So we have three part in our for syntax. So this is the first part, then the semicolon, second part, then semicolon, then third part. Okay. So first part, that is called as the initialization part. Okay, we initialize some value. This is a second condition value. Then this is the update value, increment the variable, increment or decrement the value, and this is called as a loop body. So how our instruction executes? First, this operation, initialization operation, performed one time. Then this condition is checked. This condition is true, we enter inside this body. And after executing this body, we will come at this step. Okay, update our variable, then come to this condition again. Then if again this condition is true, then we will enter, then will again come this update condition. So in this way our iteration operation is executing. So same cycle we have mentioned here, initialization only one time, after that condition, then body, then update the variable, again back to the condition. So you can see this example here. This part is now initialization. Okay, I is set to 1 initially. Now we are checking I is less than equal to 5. Yeah, 1 is less than equal to 5. So we are entering inside this body and printing I. Okay, after that we are incrementing our I. So this is a increment operator. So I become 2. Now we are checking again, 2 is less than equal to 5. Yes, again this is true. Then we are entering inside this and printing I value 2. So 1 2, then again incrementing. Okay, so I become 3. 3
Sir,
is still less. Yes.
yes, sir. So, can't we give a print 0 instead of return?
This one.
Yes, sir. What's the difference between print and return?
So this is actually related to the function topic, but regarding this main function, actually, every function actually returns something. Okay, so when we are writing any function, so that should return something, and that is depends on what data type we are deciding here. If we are deciding integer, so some integer value should be written by the function. And this return statement means, printing means that value will be print into the output console. Output console, in the previous example you can see in this code print, we are using this print statement, and this Monday is printing in our console, this here. Okay, on the right part, this is the another user interface actually, where we can give the input and where we can see the output. So this print statement is printing the value in the console, but return statement is actually, it returns the value to the same code. So that we can understand by some function. So let me just tell you one basic functions. Okay, so like int, I'm just writing like a that add basic function. So it is taking two value, int a comma int b, reading the value, and after that this is performing sum, int sum equal to a plus b. Okay, and it is returning return sum. Okay, and what will happen, so let me just write the code again. So I'm taking some value here. So int a equal to 10. Okay, int b equal to 20. We can take any variable name, no need to take the same. Okay, so let's take x, and this is y. Okay, now these two value we have, what we can do, we can write int res result equal to, and we can call the above function add, and we here we will pass the value x comma y. So when we are writing this, and now we are printing our result, so printf %d and comma that res. Okay, so now what is the difference? So you can see this is the function with name add, and this add function returns a value of integer type. Okay, and what that value is actually sum of the input a and b. And inside the main function we have two value x and y, and we are calling this function add. Okay, and we are passing this value x and y. That means 10 and 20 we are passing. So x value will be passed to a value. Okay, so that means this 10 will be stored inside this a, and this 20 value will be stored inside this b, new variable for add, and that will be used inside this function, and you will get a 10 plus 20 30 sum, and the 30 will be returned by this function. So that value will be replaced here completely. So you will get a 30 res equal to, so this complete function will be replaced by the this sum value 30, and this 30 will be assigned to res, and that will be print here. Okay, so return means this value is returning to the same code. Okay, this will not display in your output, that console. This console is different. So that means the function is returning some value into the same code, and then after reading that value inside this code, we are printing this, then this is coming into the console. So you can see we are getting 30. So this last print statement is printing 30 res value. So where from this 30 is come from inside this res. So this actually add function is now returning some calculation, and this complete part is replaced by the this return value sum. Okay, so this is actually a return things. What is return and what is print? Print is just a printing the some strings in the console, that output. Okay, so what res value we have, that will be replaced here 30, and this 30 strings will be printing in the output part. So everything in the console is actually a string form. So but this main function, this return statement 0, why this is required? So this is related to some operating systems. So 0 is just an indication to the operating system that this program is executed successfully. Okay, so that means when we are running this program, this 0 will be returned to the main operating system where the compiler is executing to that, and 0 is just a sign for the operating system that without any problem in the operating that computer, it is executed successfully. If this failed due to some any other error or any system configuration or any other memory deallocation like this type of error, so it will return something else message like 1 or 3 or 5 like this type. It's main function return statement. Okay, so this generally main function we write this 0. Otherwise you can also avoid this, you can write void and just remove this. Okay, otherwise this is just a fixed thing you can write in the every main function, but return you can use like this in the user defined function which you can define. Okay, so this is about the return.
Okay, sir, understood.
Yeah, so come to the loop. So this is the loop we are performing like this. So every time this incrementing is happening, and at any time, so 1 2 3 4 5, so that means 1 2 5. So you can see equal sign is there. So that means when our 5 is now become equal to less than equal to 5, so that will print. But after that our I will become 6. At the time 6 is less than equal to 5, this condition is false. At the time our loop will break. So this value will be printed in the output. So in this way this for loop is running. So now in this way you can perform any operations, so like sum of first 10 natural number. So you can run a loop 1, you can start from 1, this is the last condition, every time it is incrementing by 1. You can also change this. Okay, you can also write like I equal to I plus 2. So what will happen, I will be incremented by 2 every time. So I is now 1, then it will become a 3, then 5, then 7, then like this. Okay, so you can write this expression according to your need. So by default this I plus plus, if you're writing this, so that means it is incremented by 1 only. So according to your need, you can just write your initialization condition and this updation. Okay, and you can also write this statement inside this block after the expression. Okay, and you can keep this empty. So both are the equivalent. So this is the loop. Loop means iteration. So that means we want to perform same type of operation multiple times. So at that time we use the loop. And we have the another type of do while loop. Okay, so just this is the important things. Infinite loop, avoid this. Um, just always do not skip the condition. Okay, you are taking the condition, but do not always update the variable, and your loop should be moved to the condition. Okay, so if your that loop variable value should be moved to this condition, and that should not be far from this condition in every iteration. So here you can see we have not written update variable. Okay, so that means I will remain 1 always after every iteration. So this condition will always be true. So our loop will run infinitely. It will not stop. Okay, so avoid this type of such conditions. So just write your proper syntax so that your loop should terminate after some iteration. So similar while loop we have, we what we can do, while is have one condition and our condition is true, our body will be performed. Other condition is false, then we will come out. But before condition, we just set initialization in the while loop. So you can see this is the simple syntax. And in normal program, this is also very similar to the while for loop. Here we perform initialization like this before the while loop. Okay, so that we take some variable or any required variable and we set initialize something to the value. After that, we use that variable as for the condition. So I is less than equal to 5, and we update that variable inside the body itself. Okay, so all these things we are doing similar to your for loop. Initialization is happening, condition is also there, and updation is also there. Okay, so if condition is true, we will enter inside this, and after updating the variable, if condition is false, then we will come out. So this is the while loop similar to. Okay, so same operation we can do, same infinite loops you should avoid. So while one means true. Okay, and if you are writing while 0 means false. So true, if we are writing this condition, so this loop will always run. It will not stop. We are not writing any termination condition. So this will always true and it will run infinitely. So our loop should be terminate properly after some iteration. So you can update like this. So here condition is there, updating is there. And we have one another type of loop, do while. So do while loop is just provide a things like that. We will at least one time we will perform the body execution, then we will check the condition. In the above condition, first we are checking the condition, then we are entering inside the body. If our condition is false in the first time, we will not enter the body. But in this do while loop, we will enter at least one time in the body, then we will check the condition. Okay, so this ensure that at least one time your body will be executed. So you can see do while loop. So that means do first this, then check the condition. If condition is true, again do. Okay, so this is also very similar. So now these are the example. Just check these documents. Nested loop inside the loop. We have this. So yeah, this is also important questions can be asked. Nested loop. So nested loop means we are running one loop inside the another loop. So this loop we are running inside the above loop. So every value of outer loop, we will complete this part. We will finish this part completely. Okay. Then we will move to the next iteration. So you can see here this time rows are 4 and columns are 6. Okay. So this is 4, this is 6. And we are printing this asterisk. So what will happen? For I equal to 1, we will send 1 is less than equal to 4, condition is true, we are entering inside this. But this is another a loop. So this loop will run completely. Okay, this part will completely execute first, then we will come back to the next iteration. So then we will start a new loop, j equal to 1, and this is 1 is less than equal to 6. Yeah, this is true, and then we will start print. Okay, and after one space, this loop will run again. 2, another asterisk will print. Okay, then 6 times this loop asterisk will print in the one line. Okay, by inside this loop. Okay, 1 2 3 4 5 and then 6. Okay, 1 to 6. Then this loop is now completed. This print statement will perform. So this is new line character. So that means our cursor will come in the next line. Then our next iteration will perform. I will become 2. Okay, so by this operation, I will become 2, and 2 is still less than 4. So that means again this loop will perform. So again this 6 time stack will print by the inner loop. So 6 times, this is the first time, this is second time. So 1, 2, 3, 4. So 4 times this pattern will be print like this by this nested loop. Okay, so every value of outer loop, this part will execute completely, then this instruction, then you will come back to this. Again, this part will execute. So this is like a nested loop structure. So you can, so this is one more break, continue, and go to statement. So break is actually a statement to break the loop. Okay, so suppose we are running this loop. This is running from 1 to 10. But if any time if our I become 5, we are using this break. So that means our iteration will stop. So that means we are printing our I value. So 1, 2, 3, 4. And when our I become 5, so this break statement will actually break this loop and our control will come directly outer of this loop. So only this output will be print by this. So break is used to break the iterations at any point. And it breaks the closest loop. Suppose if you are using another nested loop, so that means which loop will be break? So the loop which are actually this break statement, which loop is closer to this. Okay, so this loop is closer, so this loop will break. Continue statement. If we want to skip the remaining part and we want to directly move to the next iteration without printing or without executing the remaining part, we can use the continue. So here you can see this loop is running. At any time, if our number is even, so we will not print this. This is the next instruction. So if our number is even, this will be execute and directly we will jump to the next instructions. This I plus. Okay, so this part will skip. Continue means we will directly jump to the next iteration without executing the remaining part. And this go to is not too much important, so this is used before that but not too much now. So we can also use the control here. So but here we have to define the label in our program like this. So start label. At any point, if based on any condition, we can directly jump to the defined label. So go to start. So that means if we are writing like this, so we will directly jump back to this location and our execution will start from this point further. But we need to define the label like this, start or any other label. So this is the old actually way to control the things, but now we can do this by the help of if else or all these things. Okay, so yeah, sometimes this shortcut single line statement is also written for conditional statement like this, if condition and then statement. Okay, so like this, if this condition is checked, this statement will execute. So once this termination symbol is found, that it will be actually complete the block. So just check this single line statement in this document. Okay, let's move to the problems of the mock. Generally, we not ask too much this single line statement. Okay, so it creates the confusion. So let's discuss it. Okay, so this x, okay, that too much time is okay. So x equal to 1, y equal to 1, and z equal to 0. So now this if condition is there, and you can see this statement which we have written. This is only this y plus plus is coming inside this block. This z plus plus is not coming. So if we write the equivalent code, so if x does not equal to 0, then this y plus plus is only executing. Okay, now z plus plus is coming outside of this. After that, if y equal to 0, then this z plus plus is executing, and else part is written, so else part will also be coming, and this z minus minus. So this is the equivalent code, and then we are printing y and z value. So here just check this. If x does not equal to 0, okay, this is correct. So we are incrementing y over. So y is become 2. Here this is now y equal to 2. Okay. Now we are incrementing z. So z now become, in this line, z become 1. And we are checking a next condition. So this is not a single block. Okay. So this if is separate, this if is separate. So if y equal to 0, no, this is false. And then we are coming here. So else part. So now z minus minus. So z was 1 and now z become again to 0. So y is 2 and z is 0. So 2 comma 0. So this is the correct one. Okay. So I hope this is clear. Okay. Okay, is this
Yes,
clear?
sir.
Okay, okay.
Yes, sir.
Okay,
Yes,
just
sir.
10-15 minutes, okay, or more points, we will solve this. So 1 second. Question. So next question, this second, this is loop based. So let's discuss this. Okay, so just note down all the value I and I, j, and k, not initialized. So now we are writing I equal to j equal to 0. So that means now I is also 0, j is also 0, but k is still not initialized. Now we are running a for loop. Okay, so for loop initialization part we have skipped because I we have already initialized. So I 0 and j 0, and condition is inside this I is less than equal to 10. Okay, in this condition then we are incrementing, and this single line statement is coming inside the for block. So this is single line statement. So j is equal to I. So inside the for loop, what we are doing, we are checking this condition I is less than 10 and I plus plus, and what we are doing, we are doing j equal to I. So what is happening, our I was that 0 initially. So 0 is less than 10. Okay, so now j equal to I means, so j become 0. Okay, now our I is incremented by 1. Again this is 2. So that means j become, that I become 1. Okay, so both will be run at the same time. So I is running, j is running. So I was 0, j become 0. Then this become 1, then j become 1, because this is assignment. Okay, this become 2, this become 2, like 3 3. In this way we will move to 9. So 9 is still less than 10, so then j will become 9. But after that, once more time our I will increment it. Okay, so this will become 10, but at that time 10 is less than 10, this condition is false, so we will not enter again. So at that point our I actually become 10, but we are not entering inside this, so j will remain 9 at the last point. Okay, and we are printing I comma j. So 10 and 9, this will be the last updated value by this loop. Okay, 10 and 9. Okay, I hope this is okay. So just step by step execute the instruction of the code one by one. Most of the time we not give this type of syntax now, the single line statement, but still check the document and understand the equivalent code. Okay, and move to the next. So 13 question. Okay, so this question you can see here, two separate conditions are there. If x is greater than x is greater than 2, then this expression is solving x equal to x into 2. Then second condition is if x is greater than 4, then we are assigning x equal to 0 and printing the x. So what it is asking that consider the following code script where x is an integer. Which of the following statement is true? So just check, x will always be 0 after the execution of this code for any value of x.
Sir,
Yes.
sir, tomorrow I have school, sir.
Okay. So if is there any problem in last question 13, 14, 15?
No, sir.
So
Yes.
The 17th alone could you just do? So,
Okay.
because
Yes,
it has to be.
if any one of you have no problem, then you can left the meeting. Okay, so
Thank you, sir.
maybe we will try to release the solution for that. Okay, maybe in 1 or 2 days.
Okay, sir.
Okay, sir.
Hmm. So let me explain this 17 now. Hmm. So this is nested loop here. So what happening? Our one loop is running I to 0 and I is less than equal to 5, I plus plus. Okay. Inside this loop, okay, so this is one loop, and inside this loop, second loop is running. Okay, so this is nested loop. J equal to 5, and here J is less greater than I. Okay, and J minus minus, and we are printing hello. See. Okay, and this printing we are performing. So what happening? Initially, what is the I value? 0. Okay, and for 0, just enter inside this loop, and this loop is running 5 to greater than 0. So just replace by this 0. Okay, so that means 5, then 4, then 3, then 2, then 1. Okay, greater than 0. So that means these number of times this hello C will be print. Okay, we are decrementing every time. So this is the first time when I equal to 0, J will run these value 5, 4, 3, 2, 5. That means 5 times this hello will be print. Okay, after that our this loop will complete, and we will back to the next iteration I plus plus. So I will become 1. Okay, then this replace I will be replaced by 1. So that means our value will be start from 5, but it will reach at the 2, not 1. Okay, so that means J will start from 5, 4, 3, 2, only 4 times. Okay, now I will be become 2, and then J will start again 5, but it will reach at only 3, greater than 2. So 4, 3, 3 times. Okay, now I become 3, so J will only be 5 and 4, 2 times. Okay, and I will become 4, so J will only remain 5, 1 time. And then when I become 5, so that means condition is correct, incorrect. So we are not entering inside this loop. So this is the terminate condition. So you can see how many times we are entering inside the J loop. So 5 times, 4 times, 3 times, 2 times, 1 time. So 4, 9, 12, 15 times. So 15 times we are entering inside this J loop, and this print hello will be print 15 times. Okay. Is it clear?
Yes, sir.
Hmm.
Yes, sir. Now it's clear.
Okay. So yeah, these you can just try to solve. We will try to release the solution, detailed solution for each question. Okay, but it will be good if you solve by your own. This you will understand that. Okay, any other
Yes, sir.
question?
Except the 17th, I have solved already.
Okay, okay, then good. Okay, you will get less number of questions here. 20 questions are there, but maybe in exam less questions will be there, and level of the question will also be easy or equal, not difficult compared to this.
Okay, sir.
Okay, yeah. So let
Also,
me.
this session was so useful, sir. Thank you for
It's very
keeping this.
useful and it was also helpful for summarizing all the weeks.
Yes, sir.
Yes, yes. Okay,
The
thanks.
teaching was very nice, sir.
Okay, yeah,
Yes,
thanks.
sir.
Okay, so all the best.
Thank you so much, sir.
Thank you so much, sir. Good night.
Good
Good night.
night. Good night. Bye.
Thank you, sir.